Hi everyone, welcome back. Today, we will briefly discuss ionization techniques in mass spectrometry. Ionization means converting neutral molecules into charged ions so they can be analyzed by a mass spectrometer. This is important because mass spectrometers detect only charged particles, not neutral molecules. After ionization, these ions can be controlled by electric and magnetic fields. Then they are separated according to their mass-to-charge ratio, written as m/z, and finally detected to produce a mass spectrum. The basic workflow is simple. First, we have a neutral molecule. Then it is converted into ions by ionization. After that, ions are separated according to m/z. Finally, the detector gives the data output. Ionization techniques are mainly classified into two types: hard ionization and soft ionization. Hard ionization uses high energy, such as electron impact ionization, and causes more fragmentation. Soft ionization uses low energy and causes less fragmentation. Examples include chemical ionization, FAB, ESI, and MALDI. So, the key point is that ionization is the first and most critical step in mass spectrometry analysis. We will discuss electron impact ionization, also called EI. EI is the most widely used hard ionization technique in mass spectrometry. In this method, neutral molecules are bombarded with high-energy electrons, usually 70 electron volts. When the electron beam hits the molecule loses one electron and forms a molecular ion, also called a radical cation. The general reaction is shown in equation. This means the incoming electron removes one electron from the molecule, producing a positively charged molecular ion. The main feature of EI is that it produces strong fragmentation because of high energy. These fragments create reproducible spectra, which are useful for library matching and structural identification. The advantages of EI are that it gives a rich fragmentation pattern, helps in structure determination, and is a well-established technique. EI is mainly used for small, volatile, and thermally stable organic compounds, such as hydrocarbons, alcohols, aldehydes, ketones, and carboxylic acids. We will discuss chemical ionization, also called CI. Chemical ionization is a softer ionization technique compared to electron impact ionization. In this technique, a reagent gas is used to ionize the sample through ion-molecule reactions. In the mechanism, first the reagent gas is ionized. Common reagent gases include methane, ammonia, or isobutane. After ionization, this reagent gas reacts with the sample molecule. Then, through proton transfer or charge transfer, the sample molecule forms a protonated molecular ion. This means the molecule gains a proton and becomes positively charged. Now let's look at the key features of CI. It uses reagent gas, produces mostly M plus H plus ions, and causes less fragmentation than EI. Because of less fragmentation, CI is very useful for molecular weight determination. CI is mainly applied to compounds that show a weak or absent molecular ion in EI. It is also useful for thermally labile compounds and compounds with higher molecular weight. Now, comparing EI and CI, EI uses high energy, usually 70 electron volts, and causes extensive fragmentation. It is best for structural details. CI uses lower energy, causes limited fragmentation, and is best for finding the molecular weight. FAB is a soft ionization technique used for polar, non-volatile, and thermally unstable compounds. In this method, the sample is mixed with a liquid matrix. Then high-energy neutral atoms, such as argon or xenon, bombard the matrix and sample surface. This bombardment transfers energy to the sample and helps produce ions without causing too much fragmentation. FAB commonly produces ions such as The main feature of FAB is that it gives low to moderate fragmentation, so the molecular ion is mostly preserved. Next, FAB is useful for compounds like peptides, steroids, carbohydrates, and other polar biomolecules. It can also be used for direct analysis of solid or liquid samples mixed with a matrix. We will now discuss MALDI and the comparison of different ionization techniques. Before MALDI, the slide also shows Electrospray Ionization, or ESI. ESI is a soft ionization technique in which a high voltage, usually 3 to 6 kilovolts, is applied to a liquid sample. This produces charged droplets, and after solvent evaporation, these droplets form gas phase ions. ESI produces multiply charged ions, so it is very useful for large biomolecules in solution, such as proteins, peptides, nucleic acids, and metabolites. It also causes very low fragmentation and is commonly coupled with LC-MS. Now, coming to MALDI, which stands for Matrix-Assisted Laser Desorption / Ionization. In MALDI, the sample is mixed with a matrix, such as DHB or CHCA. A laser pulse strikes the matrix and sample mixture. The matrix absorbs the laser energy and helps in desorption and ionization of the sample. After ionization, the ions are sent toward the mass analyzer, commonly TOF, or time of flight analyzer. The key features of MALDI are that it uses a matrix, produces mostly singly charged ions, causes very low fragmentation, and is ideal for very large molecules like proteins and polymers. MALDI is commonly used for proteins, peptides, polymers, oligonucleotides, and biological samples. Now, if we compare the ionization techniques, EI is a hard ionization technique. It uses electron bombardment, gives high fragmentation, and is best for small volatile compounds. CI is a soft technique. It uses chemical ion molecule reactions, gives low fragmentation, and is useful for molecular weight conformation. FAB is also soft. It uses high-energy atom bombardment and is good for polar, non-volatile compounds. ESI uses electrospray of charged droplets. It produces multiply charged ions and is best for large biomolecules in solution. MALDI uses laser desorption from a matrix. It produces mostly singly charged ions and is best for very large biomolecules.